This is going to be a short video showing the solutions to the topic 11, additional problems. Questions 9 and 10. So these are both word problems, and they both involve understanding that you're dealing with a word problem that's going to give you an equation that's a quadratic. And in this case, what matters, and this is why we even bothered learning about quadratics, is that they have this minimum or maximum, and it's going to help us answer some business related questions. So let's look at this first one, number 9. In this problem, we're told that Lynbrook West, which is an apartment complex, has 100 two-bedroom units. Okay, so let's go ahead and write this. Lynbrook West has 100 two-bedroom units. The monthly profit realized from renting out X of those 100 apartments is given by this function P of X as negative 10x squared plus 1760 times X minus 50,000. As I told you in class, profit functions very frequently have this big negative quantity in them. That's most likely coming from the fixed cost, that we subtract revenue minus cost, and we end up usually with a big minus quantity amount. So the question here is, how many units should be rented out to maximize the monthly rental profit? Well, first of all, when you look at this equation, what you want to notice is that the profit here is not one of these linear revenue minus cost. It actually has a x squared term, so it's a quadratic. And because it's a quadratic, we know it's going to have the shape of a parabola if we were to graph the profit function. More than that, the coefficient that's in front of the x squared term, which we call the a, is negative. So that means this whole parabola is frowning, if you will. It's opening down. And that means that the vertex, right here, maybe I should put this in green, the vertex is a maximum, right? Because everything else is below it. It's the highest point. All right, so those are some important observations before we even get into trying to answer the question. So what we're told in this question is that we want to maximize the profit. So to maximize the profit, we need to identify X sub V, right? We need to know what are the number of units that need to be rented out in order to be at this vertex. Okay, so because of that, we're going to use our formula for the vertex. So we know that A is negative 10 and B is 1760. And our vertex is given by negative B over 2A. So for us, this is negative 1760 over 2 times negative 10. So these are going to be two negatives. A negative over a negative cancels. And so what we're looking at here is 1760 divided by 2 times 10, right? So I'm not adding the 10, I just converted that. This is the multiplication, is 2 times the quantity, negative 10, but now I canceled out the negative. So I'm just saying this is now a positive 10. So it's 2 times positive 10, which is 20. Okay, don't confuse yourself by canceling out negatives and thinking you're suddenly adding 10. Okay, so if we did this on a calculator, we'll see we get 88. So the question is, so we've answered where we get this maximum revenue profit, but now what is that maximum profit? So now we're going to go ahead and get the y coordinate, the height, if we were to graph this parabola, which is also in this problem, it's the profit at that value of 88. So we're just going to plug this in here. It's really simple. It involves a calculator, but we're not really doing any heavy duty math. We're just plugging in this 88. Every time that we see, that's an O, every time that we see an X, right, we're going to plug in 88 instead, and then minus 50,000. All right, so if you plug that into your calculator, what you should get out of that is that this is equal to 27,440. So the answer to the question is that 27,440 is the maximum profit per month when 88 units are rented out. Now, you may think, boy, that doesn't really make much sense. You'd think your profit would go up by renting out more units. But what could be happening is your costs are going up faster than your revenues. So that's why it's important that somebody, and you may wonder, where does this profit function come from? So this is a little more advanced than this class, but we're going to assume some business analytics people looked at all the data and built these models. So this one has this negative parabola shape. Okay, so now let's go on to problem number 10. Problem number 10 says the monthly revenue R in hundreds of dollars. So monthly revenue R, and this is going to be in hundreds of dollars. Realized in the sale of the Royal Electric shavers. So we're talking about a company that sells shavers, is related to the unit price P in dollars by the equation. So, and we're given an equation. So the revenue is going to be a function of P, okay? And it's related to the unit price, where P is the unit price in dollars per shaver. Right, and we're given this equation. So really, it's not like we're being asked to come up with it. Right? We're actually given the equation we're going to work with, and it is negative a half P squared plus 30P. So the first thing to notice is that this is a quadratic, because the P, our variable or independent variable, has a square in it. So it's a quadratic, okay? So what we're asked to do is to sketch the graph of the revenue. So in order to do that, the first thing we're going to do, if you remember the steps, is we're going to find the vertex. Now we notice that this has got an A equals -1/2, a B, so let me make sure we're clear here. That's the coefficient on the P. The B is equal to 30, and the C isn't there, so that we have that C equals 0. Okay, so the vertex A is based on, we're going to find its location is going to be a value for P. What we know about it is that the A is negative. So this is negative. So we already know that whatever this revenue graph's like, it's going to be frowning or opening down, and that the vertex is a maximum. And that's everything we know because of the coefficient of the P squared term being a negative. Okay, so where is this happening? So P vertex, now I called it P instead of X, that's fine. We can call it any letter we want. It's our input to our revenue function, which is our quadratic. So we're going to do its -B over 2A. So it's -30 over 2 times -1/2. That's supposed to be -1/2, -1/2. All right. So the negatives cancel out, and 2 times 1/2 cancels out. So we're just left with +30. Okay. So now we want to find the next step of this, which is going to be, so this is, I'll say this is like the XV part when we find the vertex. So now we need to find the height of that. So we're going to put this value in. We're going to calculate the revenue at the vertex. Okay, so it's the revenue at 30, and that's just -1/2 times 30 squared. So I'm going P is 30, right? This is our P. And we're plugging it in here, plus 30 times P, which is 30. All right, so that just coincidentally came out that way. There's nothing magical about that. So we're going to multiply all this together, and what we get is 450. So we have this point, which is going to be on our parabola, and it's the point 30, 450, and that's going to be the maximum point. So now what we're going to do is go ahead and try and get the rest of the points that we need to sketch the parabola.
Hola. Hola. Say hola when I say hola.
So now that we have the vertex, what we're going to do is calculate the other parts that we need to graph a parabola. So we're going to get the x-intercepts and the y-intercept. So let's come over here. So the y-intercept is the easier one, because all we're going to do is evaluate this function when p equals 0, or when your input equals 0. Now, normally consider that an x equals 0, but that's fine. So in this case, we have -1/2 0 squared plus 30 times 0. So the whole thing is just 0. So we're going through, and this makes perfect sense, right? If you think about it, it's what you would want it to be and expect it to be. It's a revenue function. So if you don't sell any of these shavers, you're not going to make any money. So it makes sense that we have a point here, 0, 0. Now, the other thing that we'll note about this is that, well, let's go ahead and start making our P revenue graph. And the thing I want to point out to you is that 0, 0, not only is it the y-intercept, it's actually an x-intercept, right? Because it's a value where the height of the function is 0. So we're going to have 0, 0 is one of our points. Oops. And then we're going to go down and we have 30, 450, and this is our max, right? That's our maximum. Now the question is, do we have another x-intercept? So this is an x-intercept. And it is a y-intercept. Right, so we put in the value of the input, the independent variables is 0, gets our y input. And when does it equal 0? We have an x input. So actually, I think maybe it makes more sense to write it this way. So we have an x-intercept at 0, and we have a y-intercept at 0, 0 as well. Right, so now let's find out if we have any other x-intercepts. So what we're going to do for that, if you remember, is we set our function equal to 0, and we solve. So let's take that function. It's right here. We're going to set it equal to 0 and solve for p. So it's -1/2 p squared plus 30p equals 0. So we want to know when this revenue is at a 0. So the first thing we're going to do is just factor out a p. We always try to see if there's a common factor we can factor out. And because there wasn't a c term, that means every other term in this quadratic equation had a p in it. So I'll pull the p out. I get -1/2 p plus 30 equals 0. So we know p equals 0. We already had that one. We figured that one out. And then the next one is -1/2 p plus 30 equals 0. We want to know what p makes this true. So we can just add 1/2 p to both sides. So 30 equals 1/2 p. And then we can multiply both sides by 2. And 1/2 cancels with this 2. And we're getting 60 equals p. Okay. So we wanted to put that point in. We get that when p is 60, the height is 0 there. Because that's what we did. We found out where the height, remember, this is the height, is the height. All right, so now that we have all that, we can go ahead and graph this. All right, so when we are talking about quantities, or actually the price, we're not going to pay someone. We're not going to have negative prices. We're not paying someone to buy our shavers. So the lowest it would be 0. So we know we're going to have a point there. We know we're going to have a point at 30. Now let's say this is 450 right here. So at 30, 450, we're going to be there. And then out at 60, we're back at 0. Okay, so our revenue curve looks like this. And if we were to price things out beyond 60, we'd actually be having negative revenue, which again would mean we'd be giving money out to people, which isn't going to happen. So this is basically what we're looking at here. So now the next part of this is at what unit price is the monthly revenue maximized? So we've already found that. So the answer is the revenue is maximized at when for the price of $30 per shaver. And that revenue, the max revenue is $450 hundreds of dollars. Okay, so there's 450 hundreds. So 450 times 100 is the way to think of that. So that's going to be, we're going to move the decimal places 2 to the right. So it's 450, and then we're going to add 2 more zeros, 0, 0. So $45,000. Okay, I hope that explained to you and confirmed the way you did questions 9 and 10.